88515 88515 70161644. Eight four five four 845490. 84845490.
हेलो नानी, आज बेलकी हुन्छ अहिले म कन्फरेन्समा छु। हुन्छ हैन
So we will start in 5 minutes.
Okay, sir, no problem. No problem. Sir, suppose I have to finish within 1 hour.
Yeah.
If it takes 5 to 10 minutes more for question answer, it's okay or not?
Yeah.
Huh?
Question and answers also. After presentation, 5 minutes question and
You
answers.
have, you have
Yeah.
already. Okay, no problem then.
Any doubts and queries will be cleared.
Okay. So, sir, pronouncing. So,
Good morning, Dr. YSRHU.
Sir, good morning, sir.
Good morning. Good morning to all of you.
Then 1 or 2 minutes we will start, sir.
Okay.
Sir, we will start. Already 5 minutes over. So, good morning, all of you. Welcome to Dr. YSR Horticulture University, Venkataramanagudam, West Godavari District, Andhra Pradesh, India. Welcome to Global Connect series in collaboration with Agriculture and Forestry University, AFU, Rampur, Chitwan, Nepal. The topic is integrated agriculture, aquaculture farming systems. So in agriculture, cattle, livestock, poultry, aquaculture, so horticulture. So this is the integrated farming systems. So we are encouraging from our university. In that part, we have selected this agriculture in aquaculture farming systems today. This is the topic. Welcome to this Global Connect series, 11th Global Connect series. Today is the 11th. So this is the brainchild of our Honorable Vice Chancellor, Dr. T. Janakiram sir. And with a lot of his encouragement and cooperation, we have completed 10 Global Connect series. This is the 11th Global Connect series, and in which we invite the eminent scientists from throughout the world to educate our students and faculty, update our knowledge in all aspects what is happening in the international arena. And welcome, sir. Well, today our guest speaker, Dr. Dilip Kumar Jha, Professor of Aquaculture and Aquatic Resources Management, former Director, Curriculum Development Center, Agriculture and Forestry University, Rampur, Chitwan, Nepal. Welcome, sir. Good morning, sir. And welcome to Dr. YSRHU Horticulture University Global Connect series. And before going to brief welcome, I invite all university officers on this occasion. Our Director of Research, Dr. Nanam Naidu Garu, Director of Extension, Dr. Karunasri Garu, Dean of Horticulture, Dr. S. Padmatam Garu, Controller of Exams, Dr. Venkateswamy Garu, Dean of Student Affairs, Dr. Salome Sunita Garu, Dean of PG Studies, Dr. Surikumari Garu, Registrar, Dr. B. Srinivasulu Garu, Controller, Madam Shashikala Garu, Estate Officer, Engineer Mallikarjuna Rao Garu, and all zonal heads, all associate deans, all principals, and all heads of research stations and KVKs, and all the teachers, students of Dr. YSRHU Horticulture University. It is a very prestigious the program from the university side to update our knowledge. And today, rapport is Dr. E. Jevanna Lakshmi, Assistant Professor, College of Horticulture, VR Gudem, and Dr. Y. Lakshmi Prasanna, Assistant Professor, College of Horticulture, Venkatramana Gadam, will act as rapporteurs for this program. And welcome, sir. And brief biodata, just I will read about our the chief guest of honor, Dr. Dilip Kumar Jha. Sir is expertise in aquaculture and aquatic resource management, household nutrition, outreach, school pond program, fish diversity and health management. And sir educated BSc Zoology, Botany and Chemistry, Ellen Mithila University, India, and MSc Zoology, Fish and Fisheries, Tribhuvan University, Nepal, and PhD in Aquaculture and Aquatic Resources Management, Asian Institute of Technology, Thailand. This is the education, and sir knows many languages: English, Nepal, and Hindi, Maithili, and Sanskrit. And sir visited many countries like USA, France, India, Bangladesh, Thailand, Cambodia, Netherlands, Israel, Indonesia, Singapore, Turkey, and China. So he's the world famous scientist in fisheries, especially. And sir, now he's acting as the chairman for the Department of Aquaculture, Agriculture, and Forestry, University of Rampur, Chitwan, Nepal, and also Director, Curriculum Development Center, Agriculture and Forestry, University, Rampur, and Chairman, Subject Committee of Aquaculture and Fisheries, Faculty of Animal Sciences, Veterinary Sciences and Fisheries, Agriculture and Forestry Universities, and Professor of Aquaculture and Aquatic Resources Management, Rampur. And sir, at his credit, he published 100 journals, 100 articles in national and international journals, and is very famous at the international level in aquatic culture. And sir received many projects, and he's working in many projects like USAID, Feed the Future, Aquafish Innovation Lab for School Pond Program, and outreach to increase the aquaculture efficiency in Nepal, and research granted by EU, European Union, Asia Link, and NLCF program through Asia Institute of Technology, Thailand, and a research project financed by WinRock International through its grants to IAAS, worked as a principal investigator. Several research projects granted by IAAS, AFU Research Committee, and many publications. So he has written so many books and chapters in different books. And sir is received many awards, Best Teacher Award during 2005, and Lifetime Achievement Award and during 2019, and the Scientist of the Year 2019 award during 2020, Lifetime Achievement Award during 2020, and during 21 also he received the same Lifetime Achievement Award, and Vigyan Bhushan Puraskar received during 2021, and this is the brief biodata of our guest speaker today. I welcome, sir. Really, we are very honored to invite you for this Global Connect program. And thank you, sir. Thank you very much. And now you are invited to speak on this subject. Welcome, sir. Welcome, Dr. Dilip Kumar Jha. Hello. Sir.
I have to share the screen.
Yes.
Screen share. Okay, okay.
Yeah. Okay. Sir, you can start now.
Yeah, sir. Thanks, sir, for your.
Thank you, sir.
It's really great. It's really great. And I am just, we are in academia, so it's not doing much, but doing what can do for the best.
Yes, sir. Yes, sir.
Yes, so I think it is visible. The
Visible.
screen is visible.
Visible, and your voice also clear.
Yeah. So, okay. So, thanks. It's a very good morning from Nepal, a small country, but very beautiful country in between India and China. So we are neighbor also. So Honorable Vice Chancellor of Dr.YSRHU Horticulture University, Dr. T. Janki Ram, Honorable Registrar, Directors of different disciplines, Dean, professors, head, and all the faculties who is listening me, and my dear students. It's really great, and I just feel proud to say something about aquaculture. Actually, I thought that it's a horticultural university. Earlier it was in previous, we have Tirubhavan University, and now Agriculture and Forestry University is different, completely it's a change from there. So earlier I thought that it's only the horticulture university in India, in the Palampur, Solan is Himachal Pradesh, but it's really great that you have also the different, Dr. YSR Horticulture University. Is really great to me, and thanks for encouraging words with Dr. Dhananjay Rao, who always encourage me to say something about the program and about the topic. So I have just chosen actually for you that the integrated agriculture aquaculture farming systems is going to suit you. So this is the online of presentations. So introduction, integrated agriculture, aquaculture systems, status of fisheries in aquaculture. I am going to say some, I am going to present some slides on that also, what's going on in Nepal and what's our status in fisheries and aquaculture. Then what are the challenges, and again the overall remarks on conclusion. So why the agriculture, and agriculture is the main backbone, because food security with sustainable development is a main issue being faced by the ever-growing population. Population is growing. Is just 1 month ago, it's just exactly 1 month ago that the current population of 8 billion is now expected to reach above 10 billion in 2050. So we need to increase food production several folds in order to feed the world. The increasing demand of food can be partly addressed by implementation of integrated farming systems. It may be this kind of system, I think, may be important in the point of view for the sustainable development. So integrated fish farming is a typical farming system which is characterized by waste recycling, energy saving, resource utilization, and integration of all ecological niches. So how are we going to integrate all? As our convener already indicated, that we have different forms of activities, even if we visit mostly in the rural areas of Nepal, even in rural India or other Southeast Asia, mostly it's very, very common. So aquaculture, then crop aquaculture systems, animal aquaculture systems, then animal aquaculture systems, animal husbandry, agriculture. So all these systems, if we are going to integrate each other, then it will be beneficial, and we are going to produce actually the nutrient in very low cost, where all the systems going to function to each other, and again nothing is going to be wasted. So this is the actually reality with this one. So this system is an unique system if we manage well in the actually our ecosystems where we also belong. So integrated farming systems. So integration requires the combination of parts into a whole in a farming system. This means that none of the parts or function independently, but rather are independent by the wasted output from one subsystem becoming an input for another. The efficiency of the productive capacity of the land and water at the disposal of a farmer is improved. So what are the advantages, major advantages, if you say? Then it establishes an artificial ecosystem. It's completely, because where many more places people are telling that the organic waste is coming from different ways, it is very difficult to manage. Under this system, if anyone raising, suppose cattle, the wastage goes on the aquatic system. Aquatic systems, then again it's turn for the food and maintain its systems for well functioning. So increase then again they increase the supply of human food. Even a single farm, we are going to get different types of foods which we need in the form of balanced diet, and it's all organic. This is the main point. It's all organic. Then certainly, they increase the economic return, so and raise standards of living. So everywhere economics lies, everywhere. economics. You know, if economically anyone more economic return, more production, certainly it helps to raise a standard of living. So these are the major advantages of integrated fish farming systems with different ecological aspects. So thus integrated fish farming is one of the agricultural production system involving multidisciplinary integration of technical management functions where maximum utilization of land can be achieved. In various seasons, commercial vegetable crops are raised in the integrated farm, generally fallen leaves, especially our university. It's actually, it's a YSR horticultural university. So generally say the fallen leaves, stems, any wasted portion of the vegetables used as a food for the livestock. Similarly, the animal fecal matter are used to manure vegetables. Then consequently, a naturally self-sustaining ecosystem develops with higher economic returns. So see the global, if we see the global aquaculture, capture and aquaculture production. So generally in earlier, it's mostly we dependent on it's a capture one, but nowadays capture fisheries is going down and down, then aquaculture is growing. So aquaculture of even marine waters, then other inland waters. If you say about Nepal, we don't have sea in Nepal. So here see the global culture and aquaculture productions. So aquaculture production, it is expected that it is going to grow more and more in coming years. So just is for the students, fisheries. Earlier the term, it was only the fisheries. It's a fisheries, then fisheries was completely, the term completely divided into capture and culture fisheries. It's only 3 to 4 months ago, the FAO completely separated fisheries and aquaculture. And there was great debate earlier, it's a great debate, which one is fisheries, which one is again the aquaculture. So under the fisheries capture, it's a simple formula. It's for students. It's capture fisheries if we don't have any control, no control, no control, capture anyone coming and again going to harvest fish, and there is no such type of ownership. So capture, enhance fisheries is also termed as a culture-based fisheries, where we have partial control. Most of the lakes in Nepal, even in India, many more places, lakes, they are only going to release the stocking materials, especially hatchling, fry, fingerlings. So only here we have some control, only just partial control. So you have even say this term, the culture-based fisheries, while the culture fisheries is the complete culture, complete control. So see, no control, partial control, and complete control. If anywhere, if you farming the fishes in the aquatic systems, then if it is in our complete control for releasing stocking materials, feeding, management, breeding, and everything, it's all harvesting. So it's all coming under our, if it is under control, then culture fisheries, then it's a fisheries and aquaculture. What's the differences actually? It's generally for extension worker and for especially the students. Is actually in aquaculture is any aquatic organisms. If we are going to raise under controls to achieve maximum yield. Any aquatic or even aquatic plants also. While in case of actually, fish culture, only fish. Even prawns, prawn or shrimp, it doesn't comes under actually the fish culture. It comes under the aquaculture, but not because from vertebrate only we culture like that. Okay, so it's next. So global fish consumption, if you see is data of though published in 2022, is recently published, but it's data of 2019. Is Asia the more usage, the more fish per capita consumptions, then followed by North America, then Europe, then other countries, and Oceania is more than even Asia. But if you say the Nepal, I am going to just in the next slide, it's very less. We have just see the Nepal is a land-linked country, no sea, nothing. Even land locked country, you can say. And see the photo is if we look at the map of India, then it's a narrow strip. I think most of the states of India is bigger than this. One is Nepal. It's the northern part. Population around 30 million. Elevation we have 60. The lowest one, the 60 60 meters to top is the top of the world, Mount Everest, 8,848.48 or something 0.5 meters. This recent one, otherwise 8,848 meters. So width, see only width 193 kilometers, and length, if you see the length, so 885 kilometers, and it's bordered the Indian part, western part of Nepal bordered with India, southern parts, then eastern part, and northern parts completely with China. So see the physiography of is Nepal is see upper parts. It's completely high Himalayas, high mountain ranges. Then this is the middle mountains. Then it's a Shivalik range, and our university located in this range, is and we have, if we say, though Himalaya 27%, middle hill 50%, Tarai 23%. We have some inner belts, inner Tarai. So I have included here in the data 23%. Otherwise, real flatland area in Nepal is only 17%. 17 only, sir. It's really very, even with the topography of land, even you can say it's a mountainous country. Only 17% we have flat land. So these are the river systems, and it's quite interesting. During the summer or slack season, generally before rain, even these rivers supply 60% of water in the river Ganges, which is one of the sacred and major river systems in India, the Ganga. So all these rivers, to our river system. So see the natural waters, and next to Brazil, people call is next to Brazil, we have aquatic resources or water resources, but we haven't utilized properly. So these are the data in the the reservoirs, the 5,000 hectares in the lakes, then the natural waters, then rivers, then reservoirs. We have the village ponds, and it is growing. Now growing this number, then marginal swamps, irrigated paddy fields, because fish farming in paddy fields also, then irrigation canal and highway side ditches also. So this area is sometimes going to increase and increase, like this last year data of the from the government of Nepal is 21. So we have, if we talk about the fish species, so total fish species reported in Nepal is 252, indigenous 236, and we have again 16 exotic fishes. So species under culture, carps. Carps are the major fish cultivated in Nepal. So we have 7 carp species. Then perch, we have exotic Nile tilapia, though we have indigenous, Anabas testudinus, climbing perch, but it's not under cultivation. So a species under culture, that's why I have just one. And catfish too. It's a Pangasianodon hypothalamus, the Pangas catfish, and again we have, the African catfish also, but it is restricted, it is restricted. So all these fishes belongs to order 15, families 40, and genera 122. So these are the, all the order and is actually is order and family. So generally cypriniforms and siluriforms is a major one is a dominating one. Otherwise, see all the species of fishes is most of the fish species are resembles with Indian also. Indian natural water systems also, most of the fishes. You are going to notice this fish species. Then again, it's cultivated fishes. These are all the cultivated fishes. We have Lebiorohita rohu. Northern India is most, even other places also, Andhra, from Andhra, we imported again fishes is, the larger one. Then we have mrigal, katla. Then we have exotic one, Chinese carps also. So 3 Indian major carps, the major portions under the cultures. Then grass carp, then silver carp, bighead carp, Cyprinius carpio, and we have Torputitora also. This Nile tilapia, Oreochromis. Then we have in colder regions, it's a rainbow trout. It's a very successful fish farming, Pangasius. And in research center, we have Puntius, earlier Puntius gonionotus is name change, Barbonimus gonionotus. It's Barbonimus gonionotus. So fisheries and aquaculture. So total fisheries 100 is 1046. Just is a very less metric. Is a capture. Otherwise, 83,623 metric ton only. From aquaculture, and it's a stagnant one. 21,000 metric ton is stagnant. The is catchage. So fisheries earlier is 50, 60 years is more and more, but aquaculture is growing. So fish farming in pond, sea, others, it's lakes and other places, cage culture, raceway culture. So here 73,693 metric ton fish. So average productivity is very less. See here, in some cases even up to 9 or 10, but it's generally 5.3 metric ton per contribution in is gross domestic products in agriculture 4.2, while the contribution in GDP, in the national GDP, around 1.6. Per capita fish production, even you can say consumption is 3.4 only. It's a very less if we compare. It's just I have told you earlier in the slide. So it's completely very less, and we are thinking that how can we improve this one, and due to topographical structure, it's really difficult, it's a mountainous one. So this graph indicate how the from 2001, from 2001 to 2021 is the data. So just to think on that, the culture and capture fisheries. So culture is growing. Trend of capture fisheries and aquaculture is, see, just is growing and growing. Aquaculture is a metric ton, production in metric ton. And see here, earlier sometimes it's more and more, but it's completely stable. It's a capture fisheries. Completely it's a stable one. So Employment generation is some are working on data, but it's data of 2020. So is just aquaculture also, capture fisheries also, and now capture fisheries due to ban in some of the river and closing season. So people shifted in the different way, growing vegetables and other crops near the river side or river beds like that. Then household involved is very less, 55,000. So it's not so much. It's over, just over the 55,000. So then aquaculture practice. So aquaculture practice in Nepal is a flow-through system in mountainous region, then cage and enclosure in hills we have, then ponds and swamps in southern Tarai we have. So again, why I have given this again, this is the map, of map of Nepal. So just is different. We have also province. After democracy, earlier we have king system in Nepal, at present presidential system. So is the province, province 1 from eastern to western is generally province 2, then province 3, there is a name of such province, is most of the province. So this belt, just think, this belt is, all these belt are main granary of the Nepal. I have already told you the 23%, the lands, the what we call actually the flatland, and again we have some lands in on the base of the Shivalik regions, so included. So these areas are for fish, then fruits, banana, lime, lemon, maize, milk is the main center. They are indicated. Please see that these are the super zones for farming, even milk, then rice, vegetable, wheat. It doesn't mean that other crops are not growing. Others are growing, but which one the measure, that's why if you see the blue one is for fish, then slightly, then red completely is for milk, and slightly gray is maize and other, then rice. So everyone, so this area is the main granaries production in Nepal, this one. So we call Tarai Madhya Prosperity Program districts of Nepal. So see, the waterlogged areas are converted into ponds because aquaculture is really a very lucrative ventures. Very lucrative ventures, and everywhere people are growing, and we have some government supports also. Prime Minister's from the Prime Minister's Agriculture Modernization Project, PMAMP program. So this converted, see the STP area of, I have not given more photographs, but it's unbelievable that a complete STP area of land is utilized in the hilly regions of Nepal. See, hilly regions of Nepal for the farming of is rainbow trout, exotic one, but it's going on. It's quite beneficial, but feed cost is a major constraint in feed. So fish farming system and carp's contribution is carp polyculture contributes a major portion in fish production from aquaculture. Actually, it's greater than, is over 90%. Over is 90%. So carp culture is over 90%. Among the carp, and again the carp, Chinese carp, silver carp, big-head carp, and grass carp, along with common carp, covers 60%, while 40% by indigenous major carps, rohu, mrigal, and katla. It's why, the climate, if we talk about the climate and temperature, then this fish is more mesophilic in nature. Actually, the cool water ranges, while our indigenous this major carps, or even we can say Indian major carps, the range is lesser than that. Is a thermophilic one, warm water fishes, then cool water fishes, and cold water fishes for you already, you know. So generally, you know, previously in Nepal is 3 years already back is we have COVID also. COVID impacted even in the farming and others, you know, and affected education system also. We are in the university, so it's also, and all the academic calendar is also disturbed. However, it's not a part of, but I am telling you just the information what's in Nepal. So what's going on? Why is it very common and sustainable? Is actually grass carp. Grass carp is the fish which feeds all the way in the feeding zone of the pond. Then all the fish, all the excreta are coming in the pond bottom soil. Then again it is going to, again, it produces plankton. So for phytoplankton, silver carp, and to some extent also the bighead carps, but is again consume zooplankton, the major portions, then common carp. So all utilizing is, you know, is really a scientific system. Even we can follow, you know, the column feeder rohu, then again others also, we go, then katla, we have surface feeder, rohu column feeder, and mrigal the bottom feeder. So it's also unique, but due to mesophilic natures is also thrive in cool water. That's why we have imported these fishes from, you know, abroad, even in China or other parts. Okay, so what are the factors for technology dissemination centers, the agriculture knowledge centers? I have already talked with Dr. YSRHU. He told me that your dissemination centers working on that. So what factors affecting species selection and stocking dates in carp polyculture? Mostly the water temperature, then pond fertilization practices, feeding habits of fish, tolerance to pond conditions, and market value. It's very essential. You know, in Nepal, we fetch high price for rohu rather than silver carp and other carps. Rohu fetches high market price, you know, and harvesting and stocking in rotation. So this one, then if again it is beneficial, who is working on this, or the progressive farmers for on the feeding habits, anyone going to select these species, so please select on the basis of, otherwise if there is no exact the management, then there may be some competition. Though all these fishes are compatible, but there is a competition for food. That's why we have to think while stocking these fishes. So surface feeder, column feeder, and bottle feeder, and number, or even in the composition, it's not exactly the standpoint that we have to stay on that. No, just for the sake of information, I am telling you, you can even change, you know, little bit change, it doesn't affect. And we have in Nepal, we have, though you don't have, but most of the farmers or progressive farmers from India, they again import, you know, the big head carp. While officially in India, big head carp was not imported in India, but in Nepal, we have imported earlier big head carp, and we have successful breeding facility and everything, it's going on. So carp. So again, for it may be again helpful, I think, how many species anyone is going to farm. if 4 species, 5 species, 6 or 7 species, we have in Nepal, we have 7 species. So Katla and big head carp, it is, is more or less it's similar. It's most, it's the same, Katla and so I have not included. Even we can replace this one, Katla, with big head carp. Okay. And now is Katla is also, after Rohu is Katla fetches high price and surface feeder, and again its growth is very good. It's the fastest one under the indigenous major carp. So these are the species, and these are the combination species combinations. So all life fish, what happens while we imported, from different countries fishes, there may be some preservative in the form of formalin and others. And, in Nepal, due to, I think, long land lockedness, it's really everything going to be costly, equipment, even it's feed also. So production of fresh fish little bit is costlier in Nepal, it's costlier. So people are generally marketing such fish in live conditions. So it's expansion, and people like is because fish is a completely white meat, and it has EPA and all docosa hexonic acid, so omega-3. So it helps in preventing also the your coronary diseases. So it's good, and we produce completely organic type of fish, fish. We don't use any type of antibiotic or nothing. However, is poultry also good? It's growing and growing, but main problem with poultry is the white meat. Main problem in Nepal, we are not so conscious and other things. Even they use colistin. Colistin is the last resource for human being. The antibiotics. See, so antimicrobial resistance is really create a great problem with the poultry, So fishes, people nowadays like fish in Nepal, So this one. So what are the then challenges? If you see, for all the just to see, even for crop, horticulture, anyone, everything we need seed. No seed, no crop. Seed is really very, very determined, very important factor. Seed. So seed quality, then not only for fish, it's all the components. Those we have already discussed in previous. So seed quality, then species diversity, feed and FCR. Food conversion ratio is also one of the point. I think though 2 is not bad, but if we achieve 1.5 FCR, then it's good. 1 to 1 very difficult. If plankton and other things already there in pond, then there is a possibility. Otherwise, if you provide 1.5 kg of feed to produce 1 kg of fish, it's okay. I think it's profitable. Then waste disposal, quality production, then balanced supply, urban aquaculture, then biosecurity and food safety. So these are the things. So network of aquaculture centers in Asia, whose main office in the Thailand is also working on this way, how they are going to manage this one, biosecurity and food safety. Next. So the survival, juvenile survival is also a great problem. And for everyone, though we have developed everywhere, not only in India, in Nepal and in other countries or in Asia, in everywhere, but survival, what I have seen, I have conducted one research experiment, then hapa rearing is suited best. Hapa rearing is beneficial even in the normal range, you can get around 50% juvenile survival in carps is really great, you know. So survival is the main agenda, not for only the human beings, for all in an ecosystem. We have to maintain ecosystem, even for ourselves, you know. Is really is terrifying that what is going in the future is a climate change and other effects and everything. So the survival. So if anyone going to rear in Hapa rather than open is, I think, beneficial. This point is very, very important. And already published, you know, Ilsbeer aquaculture and others, their dose is probiotic. Probiotic also affected, you know, but it totally depend on what kind of probiotics and what the quality of probiotics, you know. Otherwise, I think it's a hatchling stage. What I found, the hatchling stage is okay, but other stages little bit effect on growth, but there is no effect on his advanced fry. Up to fingerling stage, is I have not seen any effect of this, but there is dosage and other things, but not such. So management is very, very important, you know. And again, this probiotic actually in the juvenile, because immune system is not properly. That's why I think if we support the like this, any immunostimulant, any things, then it is going to again, you know, promote the survival. So see a small scale integrated rice, vegetable, fish, buffalo, pig, fish, and others. So in is a Nepalese one, somewhere piggeries and others, but in some of the ethnic groups, you know, they don't like pig, you know. So mostly rice and others, then vegetables. So just horticultural crop come fish farming. So generally pond dikes can be used to raise vegetables, you know. So banana is planted in row on the dike of the pond. The leaves of banana are used as food for the grass carp. The waste of grass carp act as green manure, which boosts biological productivity of the pond and consequently enhances the fish production. And under such system, we don't need any fertilizer and feed, you know, because most of the fishes are, you know, is a plankton feeder. Even only little feeds, so we are going to curtail the feed also here. So this one, but please be careful that monoculture of grass carp is not possible due to after a certain stage, if you reach the carrying capacity of pond, then it is going to, you know, due to asphyxiation, there is a case of mortality. We have conducted such kind of research, and we find that monoculture of grass carp is not successful, and that's the reason. So see, it's very simple. Everywhere you can, is even river bedside, though some agencies is also preventing the use of plastic actually in the pond, but the area where the soil is not good, if clay soil or loamy soil, it's okay. If no such type of soil, then it's really difficult to manage. And within fraction of even second, I haven't got any information that any fish can be farmed without water. So water is really a very essential, you know, factors. And even in the water, the dissolved oxygen is the most critical factor for fish farming. So it's really very, very important. We have to manage all these systems. Then see this one, the bottle gourd. So bottle gourd is different from different. It's not from Nepal. We one side we have also, but no, this figure from I think is from Bangladesh, and some of the is bottle gourd is a completely different shape in the. It's a little mountainous area. I found like that. So you can grow very easily, and it's very easy to grow. These vegetables, you can very easily use the pond and other parts. It's open, so sunlight also necessary for farming, also fish farming. So please, if you manage this one, it's really great to again get more income. So this one, see, the other is a banana plant, it's a cucumber. Then some ponds and adjacent area, if they grow rice also. So if water is going to down, or if you harvest rice, then again it's fishes come in the pond. So we can manage. Technology is available, but main thing is how are we going to manage and others, because nowadays, if we talk about the rice fish farming, it's also lucrative venture. Earlier, it's really very growing, but recent days, what is going to happen? It's a trench. You have to make peripheral trench or central trench for this. Otherwise, it's really difficulties. But main problem with rice fish farming that we have to create awareness in the farmers. If anyone going to use pesticides, insecticides, because it's the variety, it's retained high yielding varieties are growing, and it needs the control of pests, then it's really difficult for fish to grow. That's why in reality, I am telling you, it's going to, it's people are living this one, because very difficult to manage in the mass levels of cultivation, very difficult. Who you are going to just control to not to use pesticides and others, high productive varieties of rice. It needs more careful management, even feed and other things, manuring, fertilizing, everything. So but it is also a lucrative venture, this one. We use generally common carp and Nile tilapia for stocking. Even snakeheads are also, especially the marel. Marel can be grown, but for seed, it's not availability. We have to collect from wild, then only it is going to like this. And again, so what are the gaps in knowledge actually? In the Nepalese perspective, I am telling you, or even in the world scenario, actually, the lack of appropriate data to identify vulnerability in fishery sector. This sector is also very vulnerable. Actually, some floods, due to some floods and sometimes droughts, and we all are facing is changing, climate changing everywhere in the world, not only our neighboring country here and there, is not only, but everywhere is changing wind. So scaling of research facilities to support key experiments and field work on river and lake habitats and sustainability, but sustainable, everyone telling that sustainable development, but how are going to achieve? So it's really very important point for the university, that we have to carry out research on that line. and investigations of the risk of increased incidence of pathogens, for important aquaculture species during climate change. It's also important. Disease outbreak also very, very difficult. Some species are species specific. Some diseases, is quite interesting. While visiting in the farm or in the field, I wonder to see that some species are not affected, only some species are affected. So some pathogens are very specific and only some species are affected. So these are the knowledge. And our university, previous we have Tribhuvan University, and same place, same, everything same, but some parts is changes into then make, we don't have earlier any agricultural university in Nepal. However, in India, many more. Even I think in a state, in all the states, there may be agricultural university in India. But so that's why we formulated for the better research and quality research and solving the farmers' problem. So Agriculture and Forestry University in 2010 accredited, and again it is on the process, and we are under the way to again flourish the quality education. So here, this is the only university in Nepal, the cater fisheries program, bachelor 4 years bachelor program. We have 4 years Bachelor of Agriculture program, 2 years Masters, 3 years PhD program in agriculture. Similarly, in fisheries program, we have 4 years Bachelor in Fisheries program, Bachelor program, and 2 years Master program, and 3 years doctoral program is a PhD. And we have veterinary also. So 5 years is a veterinary BVSC and H. We are going animal husbandry. So Bachelor of Veterinary Science and Animal Husbandry program. And our faculty, we are under the faculty of Animal Science, Veterinary Science and Fisheries we have. And we only enroll, for everyone's information, only 20 students in Bachelor of Fisheries. Only 20 students, all over Nepal. One Bangladesh, from Mymensingh, Bangladesh Agriculture University, one professor recently visited our place. He told me on an average around 2,000 to 3,000 bachelors producing in Bangladesh. Maybe in India, again, more and more. You have, again, Fisheries University, and we have MOU, Memorandum of Understanding, with Tamil Nadu Fisheries University in Thoothukudi, earlier Tuticorin, I think, So we have, and our students visited there due to COVID, we have not visited from 3 years, but I think if COVID again, if Corona subsidized, again is continue. So only 20 students enrolled, under the Bachelor of Fisheries program. And this is the only university who caters 4 years BSc Fisheries program in Nepal. So we are on the way to finish, as time permitted. So the integrated approach, the agriculture, aquaculture, and when livestock, even chicken, ducks, everything. I have not included all because we have to finish in our time limitations. Anyone interested, please visit. So just to see the integrated approach of agriculture, aquaculture, and under the agriculture, everyone, even aquaculture, so somewhere, even if it's, but it's the aquatic one. Okay, so enables an effective utilization of both land and water resource and greatly enhances economic return while lowering production costs, sustainable aquaculture development must be advanced in a manner that is environmentally sustainable, that protects the quality of the environment for other users, while it is equally important for society to protect the quality of the environment for aquaculture or overall all the agriculture enterprises. So again, I am thankful to our organizer and I am grateful to our Vice Chancellor, Dr. T. Janki Ram. I received the invitation letter from him, and it's a small country, but it's really a beautiful country, Nepal. Please visit Nepal. I invite you all to visit our place and see what the facility we have, and we can again collaborate our systems, even research and other things. We have fresh water and you have also the inland waters. So again, we can make a collaborative gesture for this work. So thanks again for providing me an opportunity to say something about this one. If any questions and query, I am really happy to answer. Thanks, sir.
Thank you very much, sir. Excellent presentation on integrated agriculture and aquaculture farming systems. And I have covered the Nepal beauty and structure and longitude and history of Nepal and the statistics of different fish types, the statistics of fish of Nepal, and especially horticulture, fish farming, especially that cultivation of vegetables like bottle gourd, cucumber, ridge gourd, bendi, and in the rice fields also, how it is cultivated. And really is a wonderful speech talk, sir, and lecture on integrated farming systems. Welcome. Thank you, sir. Thank you very much. And now it is time for the question and answers.
Yeah, it's your greatness, sir. I don't know. I really satisfy our audience. Anyway, yeah, because it's integrated, it's very long and again, but I minimize it and again. Okay. Thanks, sir.
Yes, sir. Yes, sir. Any question and answers from the audience?
Sir, good morning, sir.
Yeah. Good morning. In our place, it's no. Okay. Good morning. Good afternoon. Yeah.
Good afternoon, sir.
Yeah.
Sir, really, the presentation is very fascinating, sir. I have only one question with regard to the probiotics, sir. How much percentage of survival it has improved the probiotics, sir, on the fish seed?
Probiotics, is around 70%.
Wow.
Around 70%. If I will get time, then again antimicrobial resistance, and in probiotics I will going to provide, this one. And I am really happy. And in your country, you have December, January, like that. We don't have this month in Nepal. Our official month is now we call Pus, then Mag and Phagun. So I wish Happy New Year, all the audience also.
Thank you, sir.
Because it's January coming. So, and I have already given my phone number. I am in WhatsApp, then again in mail ID. So I will provide my paper also.
Thank you, sir. Thanks.
If you need, if anyone going to carry out researches on that. Thanks.
Dev Prasad Reddy is working and is a fishery scientist, sir. So thank you, Reddy. Next.
Sir, good afternoon, sir.
Yeah, good afternoon, sir. Yeah.
Sir, myself, K. Viranjanelu. I am working as scientist fisheries in KVK Pandrimamidi, sir, under Dr.YSRHU Horticulture University, sir.
Yeah, sir.
Sir, here, especially in Andhra Pradesh, so many carp farmers are facing Argulas problem, sir. Actually, farmers are indiscriminately using some pesticides and antibiotics, sir. But any suitable solution for Argulas, sir?
Very good question you have. Is really great.
Yes, sir.
Even in Nepal, we are facing same problem, sir.
Yes.
We generally don't encourage any farmers to use. They use cypermethrin here. You know,
Yes, sir. Yes, sir.
trichlorophone is the best one. It's a
Okay,
bear company, Diptrex, you know,
Okay.
0.25 ppm, but it is not available. It's the safest one, what I have
Okay.
seen. And last year or before last year, one Duroclean also.
Okay.
But Duroclean again, people use is ivermectin, you know. Cleaners, I am also against to use is cypermethrin, you know.
Yes, sir. Yes, sir.
Is going. What about salt? I think salt is also effective,
Okay.
but you have to use high dose. But it's again problem with some species are very difficult to survive. And we are the great importer of fish from Andhra. Nepal
Yes,
is
sir.
imported, you know, because you produce very size is larger, bigger size fish.
Yes, sir. Yes, sir.
But they use for preservative formalin. It's not good, you know.
Yes, sir.
And some chemicals placed in the gills also. I don't know which type of chemical. It looks fresh, but it's not good.
Sir, that one Dipterex, what is the dose of Dipterex, sir?
0.25 ppm. It comes as a mg per liter, you know. Mg.
Okay.
Yeah,
Okay.
mg per liter. If available, then, you know.
Okay.
So my mail is also there. If available, then Diptrex is best. Otherwise, nowadays people use ivermectin. Generally, ivermectin used in the animals, especially, you know, small animals, pet animals.
Yes, sir. Yes, sir. Sir, one more question, sir. Here, fish farmers are facing one more problem also, sir. That is red disease, sir. Actually, here farmers are using endoflaxin and neomycin, etc., sir. But in 10 grams per ton biomass, sir. But sometimes maybe that may not cure, sir, that red disease, especially in carp, sir. Katla and rohu.
Yeah. Red is a red spot. You are right. It's a bacterial.
Yes,
know.
sir. Aeromonas hydrophilus.
Just one thing, please.
Sir.
We are what we call the like is hungry or glutton, like, you know, produce more and more. Every aquatic systems has their own carrying capacity, you know.
Yes,
While we alter such systems, then it's create a problem. So otherwise, in aquaculture, there is not much diseases, you know. It's due to when overcrowding starts, you know,
sir.
it creates a stress. So we have to manage proper volume of water and proper sanitary systems. Otherwise, using, I am not suggesting please use even antibiotics. I have seen in some places, even in Nepal, they use doxycycline, you know.
Yes, sir.
Even oxytetracycline, you know.
Sir.
So please, I think suggest is better to manage their fish and pond.
Without antibiotics.
Yeah. Without antibiotics. If
Yes,
necessary, then only. Otherwise, it's a cost. Again, cost is going to incur.
Yes, sir. Thank you, sir.
And any question from any students who is in online and really interested in fisheries? Any students? Yeah.
Sir, any questions
Yeah.
from the scientific students?
So I am really thankful and grateful to the organizer.
Yes, sir.
And
If no questions are there, I invite our registrar, Dr. YSRHU, to say a vote of thanks.
Yeah.
Okay, thank you, Dr. Dhananjay Garu, the convener of today's Global Connect series program. And Dr. Dhananjay Rao is also a Director, Industrial International Program. Thank you, Dr. Dhananjay Rao, for giving me the opportunity to propose formal vote of thanks for this 11th Global Connect series program, which is being organized by Dr.YSRHU Horticulture University for the past several months. As you told in the beginning itself, this is the 11th Global Connect series program that is being conducted by our university. This is one of the flagship programs that our Honorable Vice Chancellor has initiated this program for the benefit of the students, staff, as well as the farmers. I take this opportunity to propose my profound thanks to our Honorable Vice Chancellor for having given permission for conducting this 11th Global Connect series program by inviting one of the eminent guest speaker from Nepal. We are very much thankful to you, sir, our Honorable Vice Chancellor, who is also the chairman of today's Global Connect series program. I take this opportunity to profoundly and immensely thank our today's guest speaker, Dr. Dilip Kumar Jha, Professor of Aquaculture and Aquatic Resources Management, and who is also former Director, Curriculum Development Center, AFU, Rampur, Chitwan, Nepal. Thank you, sir, for your very excellent presentation on the topic integrated agriculture, aquaculture farming systems. I think we were really taken to a world of aquaculture in Nepal. All our participants have been really benefited a lot by your expert, lecture on this very vibrant topic. As you said, it is a lucrative venture nowadays. The fisheries, combined with agriculture and horticulture. This topic has been very well presented, sir. And your PPT slides are very, very clear, very vivid. Pictures of the present topic. We are really very thankful to you, sir, for sparing your valuable time and giving a wonderful lecture on this one of the important topic, integrated agriculture, aquaculture, farming systems. On behalf of our Honorable Vice Chancellor, Dr. YSRHU Horticulture University, all university officers and participants of today's Global Connect series, I extend my heartfelt thanks to you, sir, for giving an excellent lecture on today's topic. Thank you, sir. Thank you very much. I'm also thankful to our all the university officers and associate deans of all respected colleges, principals of agricultural polytechnics, and all the other staff members, the teachers, scientists who are involved in this program. I once again thank you one and all for attending this 11th Global Connect series. Thank you, sir. Thank you very much. Thank you, Dr. Dhananjay Rao, for giving the opportunity to propose thanks on this conduct of this 11th Global Connect series program. Thank you one and all. Thank you, Dr. Thank you, Dr. Dilip Jha. Very, very nice to meet you, sir. And today we were very much impressed by your expert lecture on this very important topic. I think we'll be in touch with you, sir. Our staff will be in touch with you, working at various colleges, research stations, and even our university staff will be in touch with you, sir, in future. Thank you, sir. Thank you very much for sparing your time.
Thank you, sir. Thank you, sir. Thanks are also due to Jeevana Lakshmi, assistant professor, rapporteurs, Lakshmi Prasanna, all non-teaching staff who are involved in this. And especially thanks to Dr. Dilip Jha, sir. Really excellent presentation. Again, we are in touch with you. Thank you, sir. Now thank you very much. And the program is ended.